The bow and arrow is an important principle of physics to address. Conversion of elastic potential energy from the archer to kinetic energy when the archer releases the arrow can be applied to many aspects of society. This principle, conversion of elastic potential energy to kinetic energy, can easily be related historically to survival and during present day in many wars around the world. Learning about how these two energies can be converted and which applications can be drawn are essential to society. This will be explained later in the video. I made this model to demonstrate the construction of a bow and arrow and to be able to make some of my own conclusions about the physics behind it. When making this model, the main issue I had was determining the curve of the bow. I had to take into account the fact that the bow had to initially be curved, but I also had to allow for more curve after the bow had been made so that the arrows could be released properly. There are multiple factors which go into how far an arrow will fly and their flight path. The potential energy from the archer is transferred to the arrow in the form of kinetic energy when the archer releases the arrow. Obviously, there are many factors affecting how far the arrow will fly. Some of these factors include the initial angle, the initial velocity, the weight of the arrow, the length of the feathers, and the height of the feathers. The initial velocity is determined by the force of the bow, the efficiency of the bow, and the mass of the arrow. The higher the initial velocity, the faster and further the arrow will travel. The initial angle also determines how far the arrow will travel. Many people believe that the higher the angle is, the faster the arrow will travel, but this is not the case. Since the arrow has been pointed up so high, it has to go all the way up, then come back down after all momentum is lost. Therefore, the arrow will not be traveling as fast. Also, the weight of the arrow is very important. Many archers aim to have a light arrow shaft but a heavy tip to maintain speed and accuracy. This is how an arrow flies and the factors which are taken into account. When a projectile is thrown by hand, the speed is determined by the kinetic energy imparted by the thrower's muscles performing work. The energy must be imparted over a limited distance, in this case it's the arm length, and over a limited time. Therefore, the limiting factor is not actually work, but rather power, which determines how much energy can be added in the limited time available. When a bow is used, the muscles are able to perform work much slower, resulting in greater force and greater work done. This work, done by the bow, is stored as elastic potential energy. When the bowstring is released, the stored energy is imparted to the arrow much quicker than can be delivered by the muscles, which creates a higher velocity and a greater distance. In other words, using muscles to throw an arrow versus using a bow to release the arrow can create very different scenarios. Muscles will create a faster speed, very little distance, and low velocity, whereas a bow will create a slower speed of work with greater velocity and greater distance. This is the same process used by frogs. Frogs use their elastic tendons to increase their jumping distance. Some energy in archery is dissipated through elastic hysteresis, which is the dependence of a system on its current and past environment. This reduces the overall amount released when the bow is shot. The elasticity of the arrow makes many other factors vary, like the energy absorbed by compressing the arrow. This is because the release of the bowstring is rarely in line with the arrow shaft, which causes it to flex out to one side or the other. This is due to the bowstring's acceleration. It accelerates faster than the archer's fingers can open, which creates some sideways motion on the string. This effect is usually experienced regardless of other materials present, and results in oscillation of the arrow. One of the many principles of physics that has been demonstrated today is the conversion of potential to kinetic energy. The archer pulls the string back with the arrow. This energy is stored as potential energy. Then, when the arrow is released, it's released in the form of kinetic energy. This principle began with survival. Hunting and killing animals through these types of weapons were carried out in order to feed families. This conversion of potential to kinetic energy was used in weapons from thousands of years ago. At this time, this was a positive impact. Men and women were able to feed their families as a result. Nowadays, as time progressed, this principle began to take a negative turn. The principle of energy conversion is used in wars and artillery in order to kill people. This is the same principle, now applied to weapons from today. The energy in the form of gunpowder is called chemical energy, also found to be chemical potential energy. This energy is converted to kinetic energy when the bullets are released. It's clear that these applications are now negatively impacting society. Originally, this was developed to kill animals and has progressed into killing other people, which has negatively impacted our society. To put this into perspective, Fred Cottrell wrote a book called Energy and Society, which demonstrates his global perspectives on energy. This can be linked to the potential and kinetic energy found in the bow and arrow. In this book, Cottrell states, "Man also makes use of converters other than his own body to achieve his ends, and the energy these converters make available to him is also measurable. Thus, wherever other converters can be used to replace or supplement the energies of man, the relative advantage in energy terms of using them over his own physical effort can be calculated." Although this is only one of the many statements he makes on energy, it's very applicable to the bow and arrow. As I said before, hundreds of years ago, men were feeding their families, hunting and killing animals using bows and arrows. Cottrell states that men have converters that they use in order to replace or supplement energy. This suggests that the bow and arrow may have been one of these converters. As I said earlier in my video, it's a lot easier to release an arrow through a bow than just by throwing it. Just by throwing the arrow, it doesn't go very far. Now I'm going to use the bow and see how far it goes. As you can see, the second arrow went much farther. This is because the bow is able to concentrate its energy, whereas when you throw it, much of the imparted energy is lost. Earlier this year, we did a projectile motions lab. It was concluded that a 45-degree angle will produce maximum horizontal distance, and a 90-degree angle will produce maximum vertical distance. This same theory can be applied to a bow and arrow. Applying the bow and arrow at a 45-degree angle will produce maximum horizontal distance, and applying it at a 90-degree angle will produce maximum vertical distance. The same theory applies. In summary, a model was created to demonstrate the construction of a bow and arrow and conclusions that can be drawn from it. The angles at which the bow is directed will affect the horizontal and vertical distance. Throwing an arrow will produce less of a horizontal distance than releasing the arrow with a bow. This is because of energy. Potential energy is converted to kinetic energy in this process. Energy is lost when muscles are used to throw the arrow, whereas energy is concentrated at the arrow when the bow is used to release it. The ultimate goal of physics principles is to create usable forms of energy out of potential energy to further technical abilities. This can be seen through the bow and arrow. Thank you for watching, and I hope you learned a little bit more about the bow and arrow today.